The engine velocity of a boat that is traveling across the Mississippi River is 20 miles per hour in the direction of 45 degrees north of east. Huh? Okay, we'll take a look at that in a minute. The current of the river is flowing at a velocity of 35 miles per hour south of east. What's the resulting velocity of the boat? So we have two vectors here. Vector 1, 20 miles per hour in the direction of 45 degrees north of east. What? Okay, so if we start with that second direction, and I'm just going to draw a coordinate plane to start with. Actually, north, south, east, west can be helpful. So when I draw this vector, I want to do 45 degrees north from the east. So starting at east, we're going to travel up 45 degrees. So my vector is headed in this direction, and this is 45 degrees. So then I can easily make that triangle I need to find the x component and the y component. The second vector, this is the current of the river is flowing at a velocity of 35 miles per hour south of east. Oh, wait, by the way, I forgot to put what my magnitude was for the first vector. My magnitude is 20 miles per hour. Write that in on there. Okay, so second one also, I'm going to do a north, south, east, west on my coordinate plane kind of. So I need to go south of east. So starting at the east, I need to rotate south. And, oh, it doesn't really say. So we're going to actually change this problem up. There's a little typo here. We're just going to say it. We're going to say it says 35 miles per hour south. So we're just going to go directly down 35 miles per hour. Remember, when we're going down, that's going to be a negative magnitude. Okay, so step 2, I need to find the x and y components for each vector. So for A, to find x, I can take the cosine of 45 equals x over 20. To find my y value, I will have the sine of 45 degrees equals y over 20. I'll go ahead and solve those two problems. Remember, again, I'm in my degree mode on the calculator. Cosine 45 times 20. So x is about 14.14. So 14.14. Okay, this the sine of 45 times 2. Oh, of course it's going to be the same because, wait. Yep, it should be the same. I didn't multiply by 20, so that's my problem. Sine 45 times 20. And it will be the same value because it's a 45, 45, 90 degree triangle. So of course that makes sense here. And then the components for B, well, x is 0 again. Y is negative 35. Okay, so we've just split apart the vectors by component. Now I'm going to add all the x's and add all the y's. So my resulting x's of 14.14 plus 0. Okay. My y is 14.14 plus a negative 35, which equals negative 45. Let's try to avoid calculator errors. Oh, and I still did a mistake. It's plus negative 35. All right, let's go back to the entry and change that to 35. Okay, negative 20.86. And by the way, these are all miles per hour. Miles per hour. I like to put those labels on. Okay, find the resulting magnitude and direction. So the x direction, we're going 14.14 14.14 miles per hour. Then we're going down, negative 20.86. So I'm looking at this as my result, and obviously this is not drawn to scale. This is just a rough sketch. I need to find my angle measure here, and I need to find my magnitude. I guess I'll call it M this time. So in order to find the magnitude, I can do Pythagorean theorem, 14.14 squared plus negative 20.86 squared equals M squared. 14.14 squared plus negative 20.86 squared. Okay, I'll take the square root of that answer. M is approximately 25.2. This is miles per hour. Okay, so I have the magnitude of my vector, but remember I need a magnitude and a direction. So let's find this angle measure that will help us notate the direction. We can take the tangent of theta, which equals opposite over adjacent, 20.86 over 14.14. Remember, we're taking the inverse tangent, so we're going to input that ratio, and we're going to get the output will be the angle. So inverse tangent of negative 20.86 divided by 14.14 gives me an angle of negative 55.9 degrees. Okay, so because my problem started with this funky 45 degrees north of east, let's see if we can get this angle measure in that notation as well. So basically, if we are headed in the east direction, we're going to rotate towards the south 55 degrees. So we could say 55.9 degrees south of east. And that's what that really means. If I were to be heading east and then I move south 55.9 degrees. So my magnitude 25.2 miles per hour in a direction of 55.9 degrees south of east.